very much. Right, question 7, differentiation. And quite a lot of marks here, aren't there? We've got 8 marks, more than 10% of the paper just on this bit. Find dy by dx in each of the following cases. Here we go. So, part 1. Well, as we just said about this, the first thing that we need to do is get this so that it's all kind of on one line so that we can deal with it. So we can't just dive straight into differentiating this as it is. So let's do a bit of the indices stuff about sorting things out first. We've got 3x all squared. That means everything inside that bracket is squared, so that would be 9x squared. That's multiplied by x to the 4 and divided by x. Still, I'm not going to differentiate anything yet. We remember when we wrote down the laws of indices, feels like a long time ago, that if you multiply these together, you add the powers. So this is going to give us 9x to the power 6. And then, by the same token, when we divide, we subtract the powers. So here we've got 9x to the 6 over x to the 1. Subtract the powers, we end up with 9x plus 5. Now we've done a lot of work there, we haven't done any differentiation. The question said find dy by dx. So finally, and probably actually only for 1 mark at the end of this, is the bit where we get to differentiate it and write 45 x to the 4, 9 times 5, and take 1 away from the power. It's a bit odd, isn't it? But it was a differentiation question, but actually probably 2 out of 3 marks there, offering you knowledge of indices and how you deal with fractions and all that kind of stuff. Then we've got part 2. Y equals the cube root of x. Okay, so again, the same thing happens here. We've got a cube root. And part of the skill in solving this question is to deal with how we turn that into a power thing. And we remember that, fractional, what was it? I can't remember the poem. Fractional indices are just like a flower. The bottom's the root and the top is the power. Brilliant. Right, so this is going to be a fractional indices, isn't it? We've got a cube root, the third root. So this is going to be x to the power of a third. And again, part of the skill was in doing that. Now we're ready to differentiate it. That's going to give us the power comes down to the front. And again, we've got to be careful here. We've got to do a third, take away 1. And if we haven't got our wits about us, we'd stumble straight into writing minus a third there, which wouldn't be right, would it? A third take away 1 is minus 2/3. And I think you're all right to leave your answer like that. If you really want to, you might feel like tidying it up and write it 1 over 3 x is 2/3. But you probably don't need to do that. I would leave it as I've left it there. Okay, part 3. Y equals 1 over 2x cubed. And I hadn't looked ahead to this, but we've just done an example just like this, haven't we? Was it even that example that I just did? It wasn't, no. 1 over 2x cubed. So the difficult bit, again, the skill in doing all of this is can we write it in index form first? And we've got to make sure we don't make that mistake. Quite a lot of people will blindly walk straight into this and write 2x to the minus 3. And that's not right. It's a half x to the minus 3. It's because 1 over 2x cubed is a half times 1 over x cubed. And that's what we're dealing with. Now we can differentiate it. Oh, that was a bit early. So dy by dx, multiply by the minus 3. So our minus 3 halves, 3 over 2. And take 1 away from the power, but remembering to go in the right direction, take 1 away from it, makes it a -4 there. Again, that would be all right as your answer. If you really want to, you could write it as being -3 over 2x4. Like that. And there we go. Quite a nice few marks. And that's maths.